Hey there, here with 2008 number 5, parts B and C, no calculator. I'd like to work out a couple of questions, this one and one other, to kind of give you a little extra work on separating and integrating to find particular solutions. So let's go ahead and take a look. Consider the following differential equation. dy dx is equal to y minus 1 over x squared, where x is not equal to 0. Part B, we're asked here to find the particular solution to the equation with the initial condition f of 2 equals 0. So I'm going to use this initial condition here momentarily after I find my general solution. So let's go ahead and separate variables. That would be 1 over y minus 1 dy is equal to, and I'm going to write this as x to the negative 2 dx. Now my variables have been separated. Let's go ahead and start the process of integration. On the left side, if you're newer to integration and all the properties of, you might use a u sub. But if you're a little bit more of a veteran, you should be at a point where you know that this is equal to the natural log of the absolute value of y minus 1. Okay, on the right side, what we're going to do is add 1 to the exponent and divide by that same number that we have as a result. So we should get negative x to the negative 1 plus c. Okay, so at this point, if you're questioning whether or not your antiderivatives are correct, you can go ahead and take the derivatives and see if they equal your integrand above. Okay, let's continue. So here what we have, and if you wanted to, you could leave this as a general solution to the differential equation in this form. But we need to go a little bit further. We got to get to the particular solution. So I'm going to actually rewrite in a form that I will prefer to work in. And I'm going to write this as negative 1 over x plus c. Okay, so I employ this initial condition 2, 0. So if I plug a 2 in for x, I should get out a 0 for y. Okay, so I'm going to plug in a 2 for x and a 0 for y. So if I plug a 0 in for y, I get the natural log of 0 minus 1, which is the natural log of negative 1. On the right side, I get negative 1 over 2 plus c. Now, the natural log of the absolute value of negative 1 is equivalent to the natural log of 1, which is equal to 0. And therefore, I will see that c should equal a half. Okay, so I'm going to continue my work here. And I'm going to look at finding the particular solution here. Okay, I'm going to write this as negative 1 over x plus a half. Okay, so here comes the process of isolating y. So let's go ahead and isolate y by taking e to the power of both sides. So that'll be e to the power of the ln of the absolute value of y minus 1 and e to the power of negative 1 over x plus 1 half. On the left side, one property of logs that you should be very familiar with is that those reduce down to the absolute value of y minus 1. And on the right, you end up getting, and I'm going to rearrange this slightly, but you should end up getting e to the 1 half times e to the negative 1 over x. Okay, you can write that in many forms, but that's the one I'm going to choose to write it in. Okay, so here we go. When I work with reducing the absolute value or ridding myself of the absolute value, what I need to do is I need to account for that with plus or minus y. Excuse me, plus or minus as the sign of the coefficient in front. Okay, now the problem with just simply leaving this as plus or minus the square root of e times e to the negative 1 over x, or I could write it as square root of e over e to the positive 1 over x plus 1. We're going to have issues with that because that is not a function, right? And our particular solutions need to be functions. Now, why is it not a function? Because we would yield two outputs. Therefore, you should get, based on your initial condition, you should get only one of those that's satisfied by that condition. Okay, so let's do a quick test on this. y would equal square root of e over, let's plug in a 2 plus 1. And let's look at the other option as well. Square root of e over e to the 1/2 plus 1 with a negative coefficient. Okay, so this value right here in both cases will be 1. So which of those two for me would yield a 0? Well, this would yield a 2. Okay, which would be the square root of e over the square root of e plus 1. This would be 0. So clearly, we want to take, in our particular solution, would be y equals negative square root of e over e to the 1/2, or to the 1 over x plus 1. There's our particular solution. Let's take a look at part C. Part C, what they want us to do is take the limit as x approaches infinity of this function y. Okay, so if I were to kind of visualize what's happening here, this would be negative square root of e over e to the 1 over x plus 1. If x heads to infinity, what would we end up getting? Well, if we were to kind of isolate this and look at limit as x approaches infinity of e to the 1 over x, that's going to approach e to the 0. Okay, therefore, this would be equal to 1. Therefore, we would get negative root e over 1 plus 1, which we could say would be 1 minus the square root of e. All right, there you have it. That's an FRQ from back in 08. Let's look at one more. Okay, very interesting example here from 2003, Form B, number 6. It says let f be the function satisfying f prime is equal to x times the square root of f of x for all real numbers x where f of 3 equals 25. We'll probably use this. Looks like in part B. Part A says find f double prime of 3. Well, if I want to know f double prime of 3, I got to know f double prime of x. That's going to require me to use the product rule as well as the chain rule. Okay, so I'm going to take the derivative of the first function. Derivative of x is 1. Leave the second alone. That'll be the square root of f of x plus the first times the derivative of the second. Okay, so we got to do a little chain rule here, but the derivative with respect to x of the square root of f of x, generally speaking, will be 1 over 2 root f of x times f prime of x. Okay, you can check that using the chain rule later on. Okay, so I'm going to write the derivative in this bracket here. This would be f prime. I'm going to compress it a little bit over 2 square root of f of x. Okay, so there's f double prime. Let's find f double prime at 3. Okay, so that'll be 1 times the square root of f of 3. Oh, convenient. Look at that. That'll be a 25 plus x, which is 3, times f prime at 3 over 2 times the square root of f of x, which again is going to be 25. So I got to find f prime at 3. F prime at 3 is based on the original function. That'll be 3 times the square root of 25, which will be 15. Therefore, f double prime at 3 is going to equal 5 plus 3 times f prime at 3, which was 15, over 2 times 5, which is 10. Let's clean this up and finish it off. Notice how you are never free of your original basic skills on chain rule, product rule, all that good stuff. Okay, so it looks like that would be 45 over 10. So if I wanted to, I could simplify that to 95 over 10. Or you can actually leave it in this form as well. Okay, let's look at part B. Part B says write an expression for f of x by solving the differential equation x square root of y with the initial condition 325. Okay, so let's separate our variables. That would be y to the negative half dy is equal to x dx. Okay, so how did I get y to the negative half? I just took 1 over the square root of y dy x dx, and I wrote this in this power form. Okay, all right, so let's do a little work to integrate. We're ready to go. Okay, clearly on the right side, I will get x squared over 2 plus c. On the left side, I'm going to add 1 and divide by that number, so that would be 2y to the 1/2, or 2 times the square root of y. You can always take the derivative of both sides and see if they match up with your integrand. Okay, I'm ready to employ my initial condition of 325. So I'm going to write a 25 in here for y and a 3 in for x. This will end up being 10 is equal to 9/2 plus c. Okay, so that's going to mean that c is going to equal 11/2. Let's go ahead and sub that in. 2 root y is equal to x squared over 2 plus 11 over 2. Okay, so the square root of y is going to equal x squared plus 11 all over 4. Okay, so let's finish this off. If I square both sides, I get x squared plus 11 over 4 quantity squared. All right, I hope that helps. See you in the next video.